To finish off our discussion about matter and the changing of matter, we're going to look at the differences between a physical change of matter and a chemical change. So let's real quickly review solids, liquids, and gases. Looking at solids, solids will have a definite shape, a definite volume, and solids are essentially incompressible. Liquids, the characteristics are an indefinite shape, definite volume, and again, incompressible. As far as gases go, gases have an indefinite shape, an indefinite volume, but gases are compressible. So keep that in mind as we talk about changes in phases. And let's start talking about physical changes and chemical changes. So physical properties are properties of a substance that that rely on the substance itself. So things that as long as it remains that same substance, it will possess these characteristics, these properties. All right, examples are color, density, melting point, and the solubility of that substance. And solubility, of course, is if it dissolves. So with physical properties, we have two types. We have extensive and intensive. All right. The extensive properties, these are things that depend on the amount of that chemical. And they include things like the mass of the matter, volume, the length, the shape. All right. The intensive physical properties, these are things that depend on the amount of the, or rather do not depend on the amount. All right, these will stay constant no matter how much of that substance you have. All right, so physical properties, think about changes in phase. And so intensive physical properties include things like melting point. They'll include other things like color. Color doesn't have to do with the change of phase. It has to do with density. All right, those are examples of intensive physical properties. So what is a chemical property? Chemical property is the likelihood that a chemical reaction will happen. All right. So when we have a chemical reaction, thing you have to remember, keep in mind that a chemical reaction causes a new substance to form. All right. That's the key concept for this video. Chemical reactions, we have new substances that form. So chemical properties can include things like rusting of a substance, the combustibility, whether it catches on fire easily, flammability, and things like that. Things that are going to cause chemical reactions to occur. All right. Those are our chemical properties. Now, a physical change. What was that key concept for this video? Chemical reactions cause the formation of a new substance. With a physical change, there is a change physically to the substance, but it remains that same substance. We have water. That water goes through a change, and we still have water. That is a physical change. So here the example, We have substance A, substance B, and in the end, we still have substance A and substance B. All right. So here we're forming a mixture. We have substance A, substance B. We can put them together, but they're still substance A and substance B. Remember when we talked about mixtures, we can separate mixtures from each other. We can separate those substances because we just have a physical change that's occurring. Nothing new is created. Examples of physical changes are changes in the phase, going from solid, liquid, liquid to gas, gas to solid. All right, those are our physical changes. If we dissolve a substance, say you're making Kool-Aid, okay, you are mixing the Kool-Aid sugar, basically, with water. You are dissolving that in water. That's a physical change. Say you take a rock and you take a hammer and smash that rock. That's a physical change. All right, you are not changing that substance into a new substance. Again, key concept. Physical changes, the substance remains the same. With a chemical change, the substance becomes a new substance. So let's look at those chemical changes. We have a chemical reaction that occurs. We have here substance A is reacting with substance B. And through that reaction, we have created a new substance, substance Q. So something new has been created. Examples of chemical changes include rusting, photosynthesis. That's one of my favorites because I've got a big background in biology. You're taking carbon dioxide from the atmosphere. You're taking water from the soil, goes into the plant, goes up into that leaf. The process of photosynthesis takes those two things, carbon dioxide and water, takes them through a series of chemical reactions using sunlight as energy. And in the end, you get oxygen gas and you get carbohydrates. You get glucose. All right, so you're starting off the carbon dioxide and water, and you're ending with two new substances, oxygen gas and glucose, carbohydrates. That's a chemical change. You're taking a substance, undergoing a chemical reaction to form a new substance. All right. Digestion's another one. You eat that food and you have chemical reactions that happen in your gut, in your intestines, and it breaks down the food into the singular components. It may break down polysaccharides into monosaccharides, and it moves that food into your bloodstream so that it can be used throughout your body for energy. And our last example up on the board is combustion. All right. So with all of these, we're taking specific substances undergoing chemical reactions to create a new substance. All right. We're not creating matter because law of conservation of matter says you cannot create or destroy matter. We're just changing it. We're changing it from one substance into a new substance. So there are some things that will be signs and symptoms of a chemical change that has occurred. Those include energy that's being absorbed or released through that chemical reaction. There may be a change in color or change in odor or the smell of the substance. With that one, think about think about if you take a piece of fruit and you just sit it outside. Let's say it's middle of summer. Sit that fruit outside. What's going to happen to it? Starts turning brown, then turns black, and then it starts to smell. That's because you have decomposers, you have those bacteria and some fungi. They're breaking down that fruit. They're taking their energy, they're digesting it, and they're changing that fruit, changing the carbohydrates in that fruit into a different substance. And so it releases a very strong and what we perceive as a real nasty odor. All right. If there's a production of gas or solid coming from a liquid, the chemical changes, it's very difficult to change these back. Think about the egg video. When I cook that egg, when I put the egg in the skillet or on the skillet and it was heating up, that heat caused chemical reactions to occur, caused changes to the proteins. It denatured the proteins and made them into a different substance. All right? I can't take that egg and uncook the egg. I can't take the proteins in the albumin or the yolk and liquefy them again. I can't put the egg back. Right? So these chemical reactions, these chemical changes are not very easy to change back. And lastly, the key concept for today's video. All right, we're starting off substance A, combining with substance B, and we're creating substance Q, which is a completely new chemical, a completely new substance. All right, that's it for today. If you have any questions, you know how to reach me. Have a great day.